Number 3 asks, which is the strongest acid? When we're talking about acid strength, what we need to understand is that the strength of an acid is proportional to the stability of the conjugate base. That sounds like a lot, but what we really mean here is that the more stable the thing is that you get, the more readily the acid wants to donate the proton, meaning the stronger the acid is. So if we have HF, HCl, HBr, HI, what are the conjugate bases of these things? What are we going to get if these lose protons? HF becomes F minus. HCl becomes Cl minus. HBr becomes Br minus. And HI becomes I minus. So we get the halide ions. So now the question becomes, what is the relative stability of the halide ions that are being produced? Now, what is the trend we want to look at here? What we understand is that these are going down the periodic table getting larger, right? So fluoride is a certain size, then the chloride is bigger than that, bromide is bigger still, and then iodide is quite large. What we need to understand is that as the halide ions get larger, they become more stable, because anytime you have a formal charge, the more that can be diffuse, the more that can be spread around in space, it becomes more stable. A larger volume can better accommodate a formal charge. Iodide is the most stable, then bromide, then chloride, then fluoride. Now, if iodide is the most stable halide ion, that means that HI must be the strongest of these acids, because the thing that you get is the most stable option possible. HI will most readily lose the proton to produce the most stable iodide ion. Whereas going all the way down to the fluoride ion is the least stable, and so HF is actually not a strong acid. It's somewhat of a weak acid. It still can act as an acid, but because the fluoride ion is so much less stable than the iodide, HI is an extremely strong acid. It will very readily lose that proton because the thing that you get is so stable. That one's going to be HI.